Hello everyone. So today we are going to learn a new subject, possibly the most important subject in this era. This 21st century, and that is not about chemistry, but a subject which directly depends on the chemistry, physics, geology, geophysics, and all these related areas. So environmental science, so a field that touches every aspect of our life. So it is not just about the studying the plants or about the people or animal or anything pollution, but it is basically a study of everything. So what makes our daily life better? So let's start. So when we are telling about the environmental science, the first thing comes to our mind that what is environment? So the environment is basically nothing but our surroundings. So here we can see that someone is sitting here on the chair in a park, possibly, and he is reading the newspaper. So here we can see that if this environment is not that good, so basically if the environment around us is not that good, so we cannot live a peaceful life. So to make our environment good, we need to think about the surroundings, basically the people around us, the animal around us, the insect around us, and all these things. So how can we make their lives better so that if we can make their lives better, like the life of tree, the life of the insect, the life of the bird, the life of the animal or the dogs, whatever is moving around us, if we can make their lives better, and obviously it will affect us so that we can also live a better life. So, and the next here, this is the insect. I'm sorry that it is like covered by my video, but you can understand the everything what is around us, so they belong to the environment. So here, this is our earth. So our earth is made of different layers, right? So all are working together to support the life. So these are called the spheres. So the first one is basically the lithosphere, which is above the earth. And so this is the hydrosphere, which is basically the water sphere. And the biosphere means which is around us, the living beings. So here the lithosphere. So if we particularly say about the lithosphere, so this is the sphere is the solid outer part of the earth. It includes the land, mountains, rocks, soil, basically the upper part. And the atmosphere, which is above us, that is the layer of the gases around the earth. It gives us air to breathe and protects us from the harmful rays. And the hydrosphere, basically, this is, as I said, this is the water sphere, the water environment around us. This is the ocean, rivers, lakes, even the underground water, which is we are basically taking out every day through the pump. So this is also belonging to the hydrosphere. And the biosphere, particularly, which is the life around us. All the human beings, we are the animals, the plants, even the tiny microbes like the insects or the bacteria, virus, all the lives around us, they belong to this biosphere. So as I have mentioned in my first slide that we should ask ourselves, why should we study EVS, the environmental science? Why do we focus that much on the EVS nowadays? Because that if we study EVS, then we can make our life better. So we use natural resources like the water we are using, we are living on the land, we are depending on the these forest products, like we are cutting the trees, we are building like new houses or the wooden like the table, chair, all these things. We are taking out the oil, the crude oil we are using in our vehicles. We are using the solar energy. So all these things matters. So here, if we study EVS, then we can understand what is the role of our environment. So what plays what? So which one plays the most important role? So how the nature is balanced, then how we should use the resources wisely so that we can use the resources for a long time, so that our next generation can live better. So how do we produce waste, and how can we minimize to use this waste so that the waste is not a problem anymore. So what to do with this waste? And the final thing is, so if we know all these things, then the consequences which are basically coming in the next decade, that will be better, much better for us, so and also for our next generation. The Earth's atmosphere is a protective blanket of gases that surrounds our planet. So it supports life by providing oxygen and regulating the temperature and protecting us from the harmful ultraviolet rays which are coming from the sun. So if our atmosphere is well equipped, that means if we have right amount of ozone, right amount of all the components what we have in the atmosphere, so we can protect us for a very long time. So we know that in our atmosphere we have 78% of nitrogen, and whereas oxygen is present only 21%. And basically in total 78 plus 21, that is 99%, and only 1% contains the other gases like carbon dioxide, carbon monoxide, sulfur dioxide, or the water vapor. So water vapor is very less in our atmosphere, but actually we are not getting any trouble for that, because when we need water, we can just take the water from the ground or from the lake or from the ocean or sea, and we can filter, we can purify, and we can make it as a drinking quality. Okay, so in the later slides, we will discuss everything, all this atmosphere, all these layers of the atmosphere in detail. The first layer of the atmosphere, which is just above the Earth, it is troposphere. And the next one is stratosphere. And the next to stratosphere, it is mesosphere. And the upper one is thermosphere. So the troposphere, this is the lowest layer where we actually live. So it can extend up to like 10 kilometers. It is also depending on from where we are measuring, because this is also, if we are measuring from the North Pole, the distance will be a little bit different than the if we are measuring it from the equator. So the next sphere, it is the stratosphere, so which is just above the troposphere. So troposphere can range up to 50 kilometer, and it can contains ozone layer, so which protects us from the UV, like UV radiation. And the mesosphere, this can extend up to 80 kilometers. So then from 50 to 80, that means almost like 30 kilometers it can range. And so here basically we can see that when we see the fall of the meteor, so here it like comes through the contact of this thermosphere and then mesosphere, and it actually burns. So it helps us, basically it protects us from this the effect of the meteor. And finally, the upper one is a thermosphere, which is basically the heated layer, which can extend from 80 kilometer to the 600 kilometer above Earth. So it is extremely hot, as I said, and for this solar irradiation and all these things are there, which are also we will going to discuss in the other slides. And most importantly, also that if this sphere is okay, then we can also send our like the astronaut to the International Space Station. So the what we have ISS, actually it runs in this sphere. So as we have seen, the first one, the first layer above Earth, it is the troposphere. So this is the thinnest layer of the atmosphere, and it can extend up to like 10 to 12 and maximum to 16 kilometers. So as I have mentioned, that at the equator, it ranges a little bit different than the North Pole or the South Pole. And in the equator, it ranges up to 16 kilometers. Here we can see. And the poles, it is at around 8 kilometer only. And 90% of the atmospheric mass, it actually lies in the troposphere. And the temperature decreases with altitude. If we go to the upper surface, the temperature drops. So this is around like 6 degrees centigrade per kilometer, and at the top of the troposphere the temperature measures around like minus 50 degrees centigrade. And yeah, we can also see that this is the only sphere where we can see the weather change. So it's raining, it's drought, it is not raining, this is the weather is cold, so everything is happens in this atmosphere. And above this atmosphere, when it is the stratosphere begins, so this the junction between these two, it is called tropopause. So that is basically troposphere is pausing there, so it is called tropopause. The next layer of the earth is the stratosphere, which can range up to like 50 kilometer from 10 kilometer above the ground, and which is very less dense. So as we have mentioned that the 90% of the air weight is lies in the troposphere. So the stratosphere is very less dense. And another important feature of the stratosphere is, so here the temperature actually increases with the higher altitude. That is contrary to the last sphere, that is the troposphere, because in the troposphere, when we were going to the higher altitude, the temperature drops. But here, the stratosphere, so when we are going to the higher altitude, the slowly temperature rises. So this is actually because of the presence of ozone. We know that the sun irradiates and it gives like all the rays, including the ultraviolet irradiation, which is very harmful for the life. So which is a threat basically. So we need to protect us from this UV radiation, and ozone layer actually does this job. So it can absorb all these not all but most of the like ultraviolet irradiation, and it protects us. So if we can protect the stratosphere as well as possible, so we are actually protecting us for our future. And one more important feature of this layer is that our intercontinental, like the airplane or the jets, they basically fly in this layer. So basically, yeah, so to avoid this turbulence from the troposphere. After stratosphere, it is a mesosphere. So after the stratopause, the mesosphere begins, so which can range up to 80 kilometer in the high. So, and here, as we have already mentioned, that the gases are very less dense, and the upper boundary is called, so this mesopause here, and this is the boundary between the mesosphere and the thermosphere, which is the next layer to the mesosphere, and which is the very high temperature. So but the mesosphere, we can see that the temperature decreases as the altitude increases, and this is basically the coldest layer of the atmosphere, and the gases in this layer absorb very little UV irradiation. So next to mesosphere, this is thermosphere, and where we have our International Space Station. That is, so we can see this, the ISS. So where we also like fly our, like we send our astronauts, and they can stay there for some time. So and they can do some research work. So they can see the outer, the atmosphere of our earth, basically the universe, they can see better from here. So basically they don't have any cloud, since the cloud only stays in the troposphere, so they can take a better view, and then they can send all this information to us, and we can research on this and to make our life better. Okay, so here this thermosphere can actually extend almost up to 600 kilometer above us. So here the temperature increases very heavily with the high altitude, and it can really absorb the solar radiation, which breaks the gases into the molecules. So, or it can break the gaseous molecules to the atoms, or the anionic form, and it produces ions. So constitutes the part of ionosphere. So this is also called ionosphere here. Since the temperatures can go up to the like 1500 degrees centigrade, so we can understand at this high temperature, so some like reactions can easily happen, so which makes this sphere very high, like high temperature. And also this sphere can reflect radio waves. So above mesosphere, we have now exosphere here, so which is basically starting from 600 kilometers above Earth, and basically it does not have any clear boundary because we don't have air anymore. So this is the vacuum sphere. And as we can see there, when we are sending the like some satellites, or we are sending some space craft like from Earth to the to the Mars, or from Earth to the Jupiter. So basically it goes through this exosphere. And satellite, actually we are sending for our like for the communication, GPS system, weather monitoring, all these satellites, they are basically rotating in this exosphere. This is the overview of the layers of the atmosphere. So we have seen that the first layer, which is just above the Earth, this is troposphere, where we live. And the second one is the stratosphere, which contains the ozone layer. And the third one is the mesosphere, where basically we see the temperature little bit slowly like rises. And next to stratosphere, it is mesosphere, where the meteor burns, and this is the coldest layer of this earth. And the fourth layer is thermosphere, which is uh, the the maximum temperature rises here, which also like it can, due to its high temperature, it can like deplete, or it can cleave a molecule to its atomic or ionic forms. And we can see here that with the like the altitude, so first when we are going up until 10 kilometer, so here the temperature drops. When we are going to the like from 50, like 10 to 50, the temperature rises again. And when we are going to 50 to 80, temperature drops. And again when we are going from 80 to above earth, so like until 600 kilometer, or here it is only 120 kilometer is zone, so again temperature rises. Okay, so this is the composition of the atmosphere. We have seen that in our atmosphere we have like 78% of nitrogen, 21% of oxygen, and all other gases are in this 1%. So basically we have argon in like 0.934%, carbon dioxide 0.037, neon, helium, methane, krypton, or water vapor, they all lies in this below than like 0.5% amount. So here is one fun fact. The total mass of the atmosphere, so whatever we are talking about here, above the earth to the 600 kilometer above the earth, so this total mass of this atmosphere is equivalent to the 5.65 billion million tons. So this is an approximate weight, not the exact weight, but so we can understand that how much pressure is on us from this air, but we don't feel it, because the pressure inside us and the pressure outside us is maintained, so that we don't feel this huge pressure on us. So we have in our atmosphere almost like 21% of oxygen and 78% of nitrogen. So what are the uses of this much of amount of oxygen and nitrogen? So we all know that we need oxygen, so we inhale oxygen for our survival. So we use this oxygen for all these processes, for our like life processes. Oxygen is present in the sugar, oxygen is present in the proteins, or like all these like many the biologically active molecules. And also nitrogen we need to make these amino acids or the proteins, or all these the enzymes what we are basically like depending on our survival. So we need all these elements. But how can we, so we can inhale oxygen and we can use the oxygen for our like for our life being, for our survival, but can we really directly inhale nitrogen? So we can inhale nitrogen, but we cannot actually use it. So we are dependent on the nitrifying bacteria or the nitrogen, so like this like recycling bacteria, so which actually converts nitrogen to the usable form. So this is called nitrogen fixation, that we will discuss in the later slides. So this is the nitrogen fixation. So this is the nitrogen cycle in our environment. So what we can see here that, so this nitrogen, I can take the laser pointer here. So here this nitrogen is absorbed and used by this nitrogen fixing bacteria, and they can make nitrogen to ammonia. So this is we have now ammonia, which is again used by the nitrifying bacteria, and they can make it this to the nitrate and also nitrite. And this ammonia also can be converted to ammonium salt by some acidic like we have some acid in our earth crust, so which can be reacted with this ammonia to make this ammonium salt. And finally this nitrate also can be like denitrification by this can be converted to the nitrogen again by this denitrification bacteria, and it can come to the atmosphere. So this whole process is called nitrogen fixation. So here uh, in our industrial process also, we can like basically fix the nitrogen by converting nitrogen to ammonia by reacting it with the hydrogen. So that actually can be done by the Haber-Bosch process, and also we can use our in vivo or in vitro processes to make ammonia from the nitrogen, so that we can study in chemistry. So in our atmosphere, we have many different gases like oxygen, nitrogen, carbon dioxide, carbon monoxide, sulfur dioxide, or even the water vapor we have. So not all are basically permanent gases. So some are permanent gases and some are variable gases. So what are permanent gases? So the permanent gases are those whose relative abundance is constant within the homosphere, that is the homogeneous mixture, like oxygen, nitrogen, carbon dioxide, carbon monoxide. So these are permanent gases. So here in the summer or in the winter or in other seasons, so these gases are homogeneous in the atmosphere. But some gases like water vapor, so these are like variable during the summer or during the winter. So in summer, with the more heat coming from the sun, we have more water vapor in the atmosphere. But in the winter, due to this dry condition, we know that the water vapor in the air is less. So here the water vapor is called variable gas. So here are some like relevant terms that we often use when we study environmental science or atmosphere, that is the homosphere and the heterosphere. So what is homosphere? The lowest 80 kilometer of the atmosphere, so where basically we have all the air, most of the air is like basically residing here, and we see all these changes of the weather. Our aeroplane can fly here, all these things, basically the most of the thing is happening here. So this is homosphere, and the heterosphere is at the high altitude where the gases are not well mixed but rather are stratified according to the weight. So if something is heavy, so it stays at the bottom. If something is lighter, it stays up on the up. So that means here basically we don't have the airflow here in the heterosphere. So here the lighter weighing gases are found. So as we are discussing in the previous slide, that the pressure on us is huge due to this air or due to this atmosphere. So we can see that. So when we are going up, the pressure is low, and when we are going down, the pressure is more. So this is simply due to the aerobic like aerobic density. So at the lower level of the earth, so this is the air is more dense, and at the upper level of the like the earth atmosphere, this is the air is less dense, which makes the pressure very low. And this pressure can be actually quantified, and if we measure this pressure, that we can see that the air is actually giving almost like 1,000 kilo of pressure on us, so which is almost like close to one vehicle. So like we are basically we are walking here and there, taking one like a car on our head, so which is unimaginable, but we cannot feel it because the inside pressure and the outside pressure is basically neutralized by the natural balance. So here is a nice depiction of the pressure change with altitude. So here we can see that this is millibar, and here the y-axis is altitude in kilometer. We can see that when we are going to the higher altitude, the pressure decreases exponentially. So here, when we are at the earth level, so here this is like kilometer is almost, let's say, 1 kilometer or in meters. So the pressure is 1,000 millibar. And where when we are going to the like 36 kilometer here, so this is very extremely low pressure. So even you can think of when we are sending the astronauts to the space, so how much low pressure they are feeling. So basically we need a special suit for them, otherwise they will simply die. So pressure varies smoothly from the earth's surface to the top of the mesosphere. So in today's class we have learned something about environmental science. So first we have learned about the atmosphere, their different levels, like troposphere, stratosphere, mesosphere, thermosphere, and at the end, this is the exosphere. And what are their components? How much percentage of the gaseous form, gases like oxygen, nitrogens are present in the atmosphere, and how can we stay safe, and what to do with this atmosphere, how can we protect ourselves. So all these things we have learned today. So most of the things, so we need to understand that our environment is basically protecting us. So if we keep our environment as clean as possible, so our future generation will live a better life. So today, so we have learned one like a deeply connected subject, which is telling us about the nature. So from the air, that we need air to breathe, we need water to drink, we need soil to grow our food. So everything what we are seeing around us that we need for our survival. So we have also seen that these natural cycles, how important they are, like the oxygen cycle, nitrogen cycle. So how basically they are they are balanced in the nature, and how we can make our life more valuable and more safe in the future. So the layers of the atmosphere, which are basically around us, they are protecting us from the harmful UV or radiation or any other effect from the universe. So they regulate the temperature. They can make our life actually like the possible on Earth. That is how we are living. So but with the increasing threat like the pollution, the deforestation, overuse of the resources, we are using our resources too much. That basically we are without thinking that how our future generation, maybe after like 1000 years, our all the resources will be finished. So then how they will survive? So it will be a complete disaster in the future. So if we don't teach ourselves now, if we don't take the necessary steps now, the future will be very very dangerous. So environmental science teaches us not just to study about the environment, but to respect it and to take the responsibility. So it's about making the smart choices today so that the future generations can enjoy a healthy planet tomorrow. So each one of us, like every one of us, should take the responsibility. So they can contribute by conserving the water, their energy. So we need to think about the daily life. So how we can make our life better, and how we can take the responsibility to make the future better. So we need to when we are throwing anything, like when we are just throwing after eating, we are throwing the plastics. So after eating chocolate, we are throwing the packets. After eating the banana, we are just throwing the banana peel. So everything we need to take care. So we need to reduce as much as the waste possible. So we need to or reduce the use of the natural resources using. So we need to use the eco-friendly product. We need to use the bio product, so that after using them, so they can naturally they can degrade, and they can just immerse in the nature, so that nature is not getting hampered anymore. So we need to think about keeping our water safe, as safe as possible. The industrial thing, we can think about the industrial waste. So all these chemicals or all these fertilizers, so they are coming to the contact of the water. So the water life, that is the fish or the whales or which are living in the water, so they are getting enormously hampered, that they are getting trouble due to this all these chemicals. So they are dying. So if they are not staying safely, so how can we stay safely in the future? And also even in the next 10 years, we are getting into the trouble. So we need to remember that the earth does not really belong to us alone. So it belongs to us, but not only for us. So we are just one part of the larger community, part of the larger system. So it is our duty to protect our earth. So let's work together to create a better world, so where the development and nature go hand in hand, and we can reduce our pollution. So in the next class, we will talk about the pollution, because the pollution is the next threat to the human being. So next threat to the nature. So pollution is one of the most environmental problems facing in the world today. So it occurs when the harmful substance are added to the environment, making the air, water, soil, or ecosystems unsafe for the living beings. So there are many types of pollutions we can see. So this is like sound pollution. We have also seen like the air pollution. We have seen the radiation pollution, soil pollution. So many kinds of pollutions are there, which are making our life much dangerous. So we have to like take care now so that we can live a better life in the future. Thank you for joining. So in the next class, we will talk about all these kinds of pollution. Thank you.